Hello, and welcome to 5 Minute Math. Today we are looking at the fifth grade concept of classifying two-dimensional shapes. This is standard 5.5a in the great state of Texas, and we are using item number 29 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got this Venn diagram, right? And so we are looking for a shape that belongs in group 1, but not in group 2. So we're not looking for something that lies in the middle there, because then that's going to be in both group 1 and group 2. We are looking for something that belongs in group 1. So this is what we're looking for. Something that's exclusively in group 1, not in group 2. All right, so let's take a look here. Contains at least one pair of congruent sides. It's going to be group 1, and contains at least one pair of parallel sides. So let's define that, because those are going to be our two key words. So the easiest way for us to think about congruent is just going to be equal, right? Same size, same shape, same distance, same length, whatever it is. Congruent sides are equal sides. Now, when you've got parallel sides, okay, that is going to be two sides or lines that never intersect. Ever, ever, ever. So you can think of these two L's in parallel, right? If you draw them correctly, they're going to be parallel. They're never going to intersect, even if you extend them on forever. So let's take a look at our shapes here. So a square. All right, so a square, does it have congruent sides? Well, yeah, I'm going to put those in green. Actually, all four sides are congruent. So it's definitely congruent, and does it have parallel sides? Let's do that in blue. Yeah, so this side is parallel to this side right here, and then you've got the top and the bottom are both parallel. So that means that square would actually go right in the middle. We're not looking for that. We're looking for one that's in group 1, not a group 2. So an isosceles triangle. Okay, an isosceles triangle is a triangle that has two side lengths that are the same, and then one is either longer or one is shorter. All right, so let's see. Do we have two congruent sides? Yes, we've got this side is congruent to this side, so we can say yes to congruent. What about parallel? No. I mean, these two connect. Obviously, these two connect, and these two connect. So I don't see any parallel sides, so this one might work. I see an isosceles triangle as having congruent sides, but no parallel sides. So let's check out my trapezoid. This is a traditional trapezoid. We can also draw a right trapezoid if we need to, but let's do this. All right, so do we have two sets of congruent sides? Well, in this case, we do, but it depends on how I draw it, because if I've got this, then I could say yes, but like I said, I could draw a right trapezoid. I didn't say which one. And in this case, no. And we have parallel sides. Yes, we have at least one. In either way, you've got the parallel sides right here, the two bases. So that's going to land more on this side, because we don't know about the congruent sides. Could be in the middle, possibly. But definitely the parallel is going to knock it out. And then a scalene triangle, right? That's just a triangle that's got three side lengths that are completely different. Which means if you have three side lengths that are completely different, I don't have any congruent sides, and I don't have any parallel sides. That doesn't even go inside. That's just going to land down here somewhere. It's not in my Venn diagram. So you see where my shapes land, right? And this trapezoid, we could draw a right trapezoid here if we wanted to. If we drew, we could flip these two, actually, and that's where they need to be. Our answer here is going to be, though, isosceles triangle.